lot of what we do is ask really simple questions about basic processes that are relevant to the atmosphere, that are relevant to technology, and we can use computational techniques to try and address and understand these at a fundamental level. It's just nice and enjoyable to learn more about the world and how it functions. Research these days is collaborative, and it's really nice to spend time working with increasingly with younger people who are bright and enthusiastic and excited and have good ideas, and to tackle projects together. We develop and apply computational techniques to try and understand problems in chemistry, physics, materials science. And the problems that we tackle are questions at the fundamental molecular scale. So we use and develop state-of-the-art, highly sophisticated computational approaches to try and answer questions about how materials behave at the atomic and molecular scale. We've developed techniques that other people can use, other scientists use to understand problems they're interested in. So computational techniques that allow them to have more accurate, realistic treatments of materials. We have also provided new fundamental insight about, in particular, about how water behaves at interfaces, and we've helped to develop the fundamental conceptual understanding about how water might behave at surfaces. And this then is important to many real-world technologies like membranes, catalysis, the formation of clouds in the atmosphere. We're working on a range of projects related to interfaces, materials, computational chemistry, and that involves the development and application of techniques. In terms of applications first, we are looking at how water flows in membranes. So we're trying to understand what it is about specific membrane materials that might optimize the flow of water through them. And that's important work because the Earth there's plenty of water on Earth, but not enough of it is drinkable. And what we can do as computational chemists is use computational approaches to understand how can we optimize the flow of water across membranes, across interfaces. In terms of another broad project that we're working on, we're also interested in improving the state of the art of the computational techniques. And in particular, when you think about interfaces and molecules interacting with surfaces, then it's very challenging to come up with an accurate computational description of these interface problems. And we're working on developing improved quantum mechanical approaches that will treat such problems more accurately. And by accurate, we mean producing results that can be verified experimentally and can help drive forward people who are doing experiments on these types of systems. I come from a very small village in northwest Ireland. Moving from there to Cambridge certainly was a culture shock. When I came to Cambridge for the first time about 20 years ago, I found it an exciting, beautiful place to live. And so Cambridge really is a very beautiful city. I was delighted to be amongst so many other enthusiastic, talented, inspiring scientists. In our group, we really do a lot to ensure that we're working as a team. Everybody working in our group has their own individual project, but they work on it collaboratively with other people. And we have lots of collaborations in the UK and internationally. We have group dinners and parties. Also, I am a keen runner, and so I've managed over the years to persuade lots of people in the group to take this up. And each year we take part in a group triathlon. We try and have a group workshop where we do some science, and then also we then go and compete in our triathlon. In my own running, I do sort of middle and long distance running, and I currently hold a world record for being the fastest person to run a marathon dressed as a scientist. This year I'm joining the chemistry department as the new 1968 chair of chemistry, and my group will be relocating from London, from UCL to Cambridge, and there are about half a dozen people who will be coming with me, and there are some new people who will already be joining me in October, and I'm hoping that from the very beginning we will have a nice, vibrant group environment and group atmosphere here in the chemistry department.